All right, let's talk about something that's literally all around us, but most of us never really see it. I'm talking about software engineering. It's the hidden blueprint behind, well, pretty much everything. From the app that gets you your morning coffee to the insane code running inside a fighter jet.
You know the feeling, right? Your screen freezes, an update fails again. Or that website just spins and spins, and you want to throw your device across the room. We've all been there. And it feels so random. But what if it's not? What if there's a real reason why so much of our digital world feels so, well, fragile?
Okay, so prepare yourself for this next number because it is just staggering. A full 86% of software projects are considered failures. No, that is not a typo. 86%. That means the vast majority of them either never get finished or they just completely miss the mark. And it's usually this perfect storm, of bad communication, goals that keep changing, and crazy deadlines. This isn't just annoying, folks. It's a full-blown crisis.
And here's the big secret. The problem isn't usually just a few buggy lines of code. It goes way deeper than that. The real issue is a bad blueprint. It's like trying to build a skyscraper without a solid plan. The whole thing is pretty much doomed from the start, long before the first line of code even gets typed.
So what does that 86% failure rate actually look like in the real world? Well, the consequences can be way bigger than you might think.
I mean, just look at the stakes here. Starbucks had a so-called system refresh that caused their registers to go down and cost them millions of dollars in lost sales. That's a bad day at the office. But it gets way more serious. Software glitches in the F-35 fighter jet program actually created problems with detecting targets. So we're not talking about small annoyances. We're talking about massive financial hits and even risks to national security.
Okay, so with this level of chaos, it became pretty clear that something had to change. A whole new discipline was needed to bring some order, some reliability to this digital Wild West. And that's where software engineering comes into the picture.
So what is it really? Well, think of it like this. It's about taking the same kind of disciplined, systematic principles that engineers use to build bridges and applying them to building software. It's about managing the whole shebang, from that first spark of an idea all the way to making sure the system is still running smoothly years down the road.
And the goal isn't just, hey, does it work? Not at all. Good software has to be reliable. It has to be easy for you to use. It's got to be secure. And, this is a big one, it has to be maintainable, which just means you can actually update it and fix it later. It's about the total package, the whole idea of quality.
So, how do software engineers actually pull this off? Well, they definitely don't just jump in and start hammering out code. They follow a process, a blueprint for building things the right way.
And what's really interesting is that no matter how complex the project is, it all boils down to these 4 basic activities. First, you've got specification. That's just figuring out what is this thing supposed to do. Then comes development, actually building it. Third is validation, which is just a fancy way of saying, does it actually do what we said it would do? And finally, evolution, because things change, and the software has to be able to change with them over time.
Okay, so those 4 steps are pretty much universal. But there are different ways, different models for actually putting them into practice. Let's look at 2 really foundational blueprints, or paths, to see how this works.
First up, we have something called the waterfall model, and the name is perfect. Just picture a waterfall. The water only flows one way, down. And that's exactly how this works. It's like a factory assembly line. You have to finish step 1 completely before you can even start step 2. There is no going back.
And yeah, the process is just as strict as it sounds. You figure out everything the customer wants right at the beginning. Lock it in. Then you design the whole system. Then you build it. Then you test it. And only then do you move into maintenance. Every single stage is like a locked gate. You can't move on until the one before is 100% done.
Now this might sound a little crazy, but it does have its advantages. Simplicity is a big one. If you're working on a small project and you know exactly what you need from day one with 0 surprises, this structured approach can actually work great. It's predictable, everything gets written down, it's clean.
But, and this is a huge but, here's the catch. What happens if your customer changes their mind halfway through? Or what if you discover a big flaw in the original design? With the waterfall model, you're pretty much stuck. Its greatest strength, that rigid structure, is also its biggest, most fatal flaw. It simply can't handle change.
And that massive problem leads us right to our second path, the prototyping model. This is a totally different philosophy. Instead of trying to build the entire perfect thing all at once, you start by building a quick and dirty version, a prototype that you can actually show to people and let them get their hands on it. The process here isn't a straight line. It's a circle. It's a loop. You gather some basic ideas, build a rough working model, let actual users play with it, and then you listen, really listen to what they have to say. Then you take that feedback, you refine the prototype, and you do it all over again and again until everyone agrees it's ready.
And its greatest strength is exactly what you'd think. It's incredibly flexible. This is perfect for those projects where the requirements are a little fuzzy or you know they're probably going to change. Users get to see and touch something real super early in the process, which almost always leads to a way better final product.
So when you boil it all down, it's this simple. The waterfall model struggles with change. The prototyping model is designed for it. One is built for predictability, the other is built for adaptability. And you can see how picking the right blueprint from the very start is absolutely everything.
Now, these models really laid the foundation for everything that came after. But software engineering never stands still. It's constantly evolving. So what does the blueprint of the future look like?
Well, one of the biggest things on the horizon is AI-driven development. Seriously, imagine an AI working right alongside an engineer, like a co-pilot. It could write all the boring, repetitive code, predict bugs before a human ever could, and even help architect these massive, complex systems. This could radically change the speed of everything.
And then there's something else that's really important: green software engineering. People are starting to realize that all this code has a real-world environmental cost. So this is all about building software that's super energy efficient, from the apps on your phone to the giant data centers in the cloud, to try and shrink the massive carbon footprint of our digital lives.
And way out on the edge, you've got the monumental challenge of quantum computing. And look, this isn't just about making computers faster. It's a completely different rulebook for how computing even works. It means we'll have to basically throw out the old blueprints and invent a whole new way of writing software, using principles that honestly sound like they're straight out of science fiction today.
So from the straight, rigid lines of the waterfall model, all the way to AI copilots and quantum code, you can see that software engineering is really a story about the constant search for a better blueprint. We've figured out how to build the incredible, complex digital world we live in today. The only question left is, what kind of blueprint will we need to build tomorrow's?